So I mentioned last time that we will be having 2 lectures for the courseware. We have the variable charts and the attribute charts. So for the variable charts, the first ones, the XNR and the XNS will be discussed by Ma'am Lori May. And the rest of the XMNR, I will be continuing it after her. Okay? So please be attentive to Ma'am's discussion. She will have some few quizzes, no, about the lecture para po as a way of test or check up if you have understood the presentation. So before I will turn over to Ma'am, maybe she will be repeating na po this one, but I will be like giving out some basic lang about statistical process control chart. So let's start. Okay. So, di ba last time, what was our last, can you type in guys, what are the, or name lang, at least makam up na to ang 6 kabuk basic tools. Sige, can you type in the chat box the basic tools that you know? So, unhanay lang. Asa to? Ako ang lecture. Sige. Wait ha, I'm looking for my PowerPoint. Dara. Masters. Quality management. I think this is the one I made. Yeah, this one. So basic lang yan, and then Ma'am will continue the other parts, the technical parts. Sige, let me see. Okay, let me see. We have Jonalyn said histogram, very good. Then April said cause and effect diagram and Pareto chart. Same goes with Jonalyn. Then we have the scatter diagram, correct? Cause and effect di ay na support na. Check sheets, correct, Jewel. And then we have the flow chart, correct? 6th. Yeah, so everything is already mentioned. So the 7th, guys, so as mentioned, it was Kaori Ishikawa who created the 7 basic quality tools because he wanted that quality is easy to understand, no? And somehow it is hard to measure quality. That's why what he did is he made it in a way, no, that statistics and numbers are easily understood by graphs. Okay, that's the purpose of having the 7 basic quality tools. And the last one that I mentioned is by far new to all of us because we don't usually use this in our kanang everyday na mag-study ta, right? Because before when we study, we just get flow chart, no? We just use the scatter diagram. If we want to know the relationship of 2 variables, then we just use check sheet if there's a need to check frequency of use or frequency that or occurrence of errors, no? So the statistical process control chart is somehow different. Okay, lahi ihang approach, and it's not always applicable to all types of data. Okay, that's the difference with statistical process control chart. So let me share my screen. Okay. So statistical process control chart, guys. Can you see my screen? Okay. So it's the 7th basic quality tool. And okay, so as mentioned, we already discussed all of this except the last one, which is the control charts. So let's just skip all these parts. Adto ta sa okay, here. So statistical process control chart, guys, or SPC, is a powerful collection of problem-solving tools useful in achieving process stability. So in short, the goal of SPC, guys, is to check how stable the process is. When we say stable, it produces outputs within the range. eliminating or reducing variability. Diba, we mentioned in the first part that the goal of having quality or increasing quality is reducing variability. That's according to W. Edwards Deming, diba? So meaning to say, we want to improve the capability of the process and the stability of the process by making sure that the variability is being reduced. When we say ma-reduce ang variability, therefore, quality is improved. And to do that is to use SPC. So, si SPC is just going to collect data and present if the process is stable and capable. Okay, so it just gives information that, hey, you're doing fine, your outputs are good within the range. Okay, now there are two types of variations, no? We have the chance causes and the assignable causes. So when we say chance causes, meaning to say, ang terma na niya is wala kung sa Bisaya pamrag saan siya pag istorya kanang dili tinuyuan. Okay? How do we say that in English? It's out of your control. Like for example, meaning to say, Ma'am Lori, may just correct me if I'm wrong, ha, kay basi nagka-exchange. Sometimes I get confused with the two. But basta the difference of the two is, si chance causes kay dili tinuyuan. It's really the environment, for example, the environment or the nature of the ingredient itself that made it not fit to the quality being prescribed. Well, the assignable causes of variation is basically you can do something about it. It's within your control. The assignable causes man siya. Like for example, maybe the machine is not anymore productive, but you still choose to use that machine because mahal ang new machine. So it's an assignable cause already. Okay? So the two chances are usually present, no? Are usually kanang found in any manufacturing company. Okay, and it's up to you to monitor and to identify if those are chance causes or assignable causes. Of course, for those causes that are out of our control, wala tayong mabuhat ana. It's either we can what we can do is just maybe the environment, the working environment la itong ma-change. Like for example, if it's the heat of the sun or the wind, or maybe the nature of our location, wala gyud tayo mabuhat ana. So what we can do is the other parts na lang where we can let's say maintain, no, like siguro create og system na cold ang iyang environment mo nang magbay na din tag mga aircon na storage areas, di ba? Like for example, you're a business of lipsticks. Of course, you cannot store lipsticks on a very hot environment or hot warehouse. So like sa Moa, when I had my first job, dito mi sa we were housing Avon na mga products, and then of course lipsticks na ilang usa sa mga main products. So there's really a cold storage wherein it has like around 10 aircon para lang ma-maintain na ang lipsticks are in good condition. And dili gid siya basta-basta gyud nga i-deliver right away. It should be in a cold van because of course kung dili cold imong van, nainita na traffic ra bas Manila. So wala gyapon gamit ang imong pag-store. Okay? And with that, of course, you cannot change the weather of the country, diba? What you can change is where you're gonna store your items. So, wala siya ang role ng SPC, no? It shows what are the causes that can be controlled and cannot be controlled. When you say process capability, it's the natural capability of the process to perform relative to the specifications of the product. So, when we say process capability index, if it's more than 100%, meaning that is how capable your system is in producing quality products. If it will be below, or if it's just one, then good. If above, the better. But if lesser, meaning to say, your system is not capable of meeting quality specifications. So that's why the computation for that, so we have a formula for that as well. It's really the upper specification limit minus the lower specification limit over your 6 sigma. Sigma is the variation or the error. Okay? So this is how a control chart looks like. Alright? So ang goal na to diri guys is we are going to compute for the UCL, CL, and LCL. Your upper control limit, your central limit, and your lower control limit. So, as you notice, 3 sigma above and 3 sigma below. Mo na i-add sila tanan, that's the 6 sigma tolerance that we allow in a process control chart. Okay? So, the first, kanang sa central limit, the first zone, so kanang ABCD guys, ABC rather, those are zones. So, ang mga nasa C zone, then they are near the central limit. Near sila sa mean or average. The B is in between 1 sigma to 2 sigma. So far away na from the center. And the A is almost near na to the 3 sigma level. Mean to say, if mulapas na sa A, then your system is already out of control. Bisag usa lang that goes out of your zone, it's considered incapable na ang process. Now, what are the ways to determine if the chart is still in control? By the way, these are the charts that we're gonna discuss. For today, it will be X and R and X and S, which will be discussed by Ma'am Lori May. And then I will be discussing next week on Tuesday, P and NP chart and C and U chart. All right, so let's start first with determining what are the measures to say na they're still in control. Basta isa lang or more consecutive points go out of the control limit. So, drawing nimo, scatter diagram nimo, nigawas na gani ang point, automatically the process is incapable because nanay outlier. It's not within your 6 sigma nga range. Okay? If 2 of the 3 consecutive points go outside the 2 sigma warning limit. So when I say 2 sigma, na siya sa zone C. Tapos duha sila there, no? So in-graph nimo duha ka buok na nadira, it's considered already out of control. Or 4 of the 5 consecutive points are beyond the 1 sigma limits. So meaning to say, gasunod 4 beyond this sa 1 sigma. So na sila sa zone B. Meaning to say, lagyo na kayo sila sa middle point or sa central or sa average. That's already kanang bothering, no? Kaya na siya pattern na nilapas gid sa 1 sigma, na siya sa zone B. A run of 8 consecutive points only on one center. So, naa sa taas tanan or naa sa ubos tanan. That is a pattern. So, if there's really a pattern, considered na siya na process incapable. Next, 6 points in a row, steadily pasaka or paubos. Still a pattern, no? 15 points in a row, naatanan sa zone C. So, man siya, di siya ganahan nga na doon sa central limit, no? Dapat good randomized pattern gid siya. Sometimes man good guys, if you feel nga murag 50 na ka book samples pero naagapon sila tanan sa zone C, maybe ang data ana is gikan ng kana ganing manipulated ang data. So there's something wrong with that. Pattern gapon na siya. So many times it will really go up, no? Basta it should be random. Okay? 14 points in a row nag-alternate up and down. Pag first saka na sa A, pag B naapod diri A pod pero nasa ubos, no? Ya, saka up, alternate, hinimo na lang na siya nga data, guys. That's also your clue, no? If your management is actually just creating or manipulating your data. 8 points in a row on both sides of the center line with none in zone C. So, tanan, wala gyud ni reach sa zone C, that's still an incapable data, incapable process. An unusual non-random pattern in the data, and one or more points duol na gyud sa warning limit, almost getting out now of your control limits. Okay? So we will be discussing also this one, the estimating process capability, fraction of non-conformance, PCR, and percentage of specification bond after XNR and XNS. Okay? Because you will understand that more using XNR and XNS. All right? So I'll be giving now the floor to Ma'am. So I will be allowing you to share screen, Ma'am. There you go.
Hello, good afternoon.
Good afternoon, Ma'am.
Good afternoon, Miss. And the third year, sakto ba, ma'am? Third year?
Yes. Yeah, 3 years lang, Ma'am, coming forth.
Yes. I hope I am loud and clear.
Yes, Ma'am.
Yes. Thank you so much, ma'am. So, Miss Kabanlit already discussed the basic or the literature about the statistical control charts. the purpose of performing SPC as one of the quality tools, and the goal or the objective why we employ or we use SPC is to identify variations in the process. And after we identify variations or points, so we will determine the causes of these variations. Okay, and then it was also mentioned after we graph our control chart, how we're going to interpret the data. But before I'm going to uh, talk to you or discuss to you the technicalities in performing the X bar and R charts and X bar and S chart, let us have a short exercise. So allow me to share my screen. So I believe you have with you a pen and a paper na ay kaubang papel o ballpen.
Yes, ma'am.
Okay, thank you. So in a piece of paper, write the letter A and then make another one just like the first one, and then another, and until you have a series of A's. I hope my screen is visible. So on your paper, you write letter A, and then another A, until we have a series of A. Okay. Done? Mga kuan lang kabuok. 1, 2, 3, 4, 5, 6. 6 A's. Okay, done?
Yes, miss.
Okay. What have you observed with your writing or the series of A's that you prepared? Hello? You may type in the chat box if there's an error sa inyong microphone. What's your observation with the series of A's that you have, or the series of A's that you prepared or that you write? Okay. Hello? The A's nga ato ang gibuhat kay dili same ang pagkasuwat tanan, ma'am. Okay. We want to make all the A's alike, but you don't, or we cannot make it alike. What do you think the reason why we cannot make all our A's alike or same? I believe it's common to everyone that all our A's are not alike. As much as we want it to be the same, different spacing between A's and mom. Okay. What causes this unlikeness or variation of the A's that we prepare? What do you think? Human error. Okay, thank you, Miss Francis. Miss Apawan. Okay, human error. Another reason or cause of variation. Wala mi gigamit na standard spacing in between A's and Miss. Okay? So naatay human error that causes the variation, and then we don't set the standards spacing. Yes, control sa hands or pen. Okay? Another cause kaha. What else? Some of us would say that the paper was not smooth. The pencil itself or the ball pen that we use, ang linya is not uniform. And the unavoidable variability in your external surroundings reacted upon you introduce the variations or the cause of unlikeness in the A's that we prepare. But are these the only causes of variability in the A's? Everything that we mentioned, do you think these are the causes of variability? Yes or no, or probably not? What do you think, class? Yes. How about the others? Yes. Yes. So all of you would agree that everything that was mentioned are the causes of variation. But somehow, katong atong giingon nga mga causes are probably not the reasons. There are many other factors. If we could but name all the reasons why we cannot make the A's alike. Okay, so as what Engineer Cabalid mentioned, there are common or special causes that lead us to this variation. And of course, it means to be able to do what we want to do is not new, and it does not belong to exclusively to any one field of human thought. It is commonly accepted. So even if you want to make the process to be alike, to be to conform to the standard, to conform to the quality, but there are things that are out of our control. So that's why we employed or we use this tool, the statistical control charts. Okay, so thank you for your participation. Okay. So the point of the illustration was we are limited to the things that we want to do. That to do what we set out to do, even in simple things in writing letter A, is making A's that are alike, requires almost infinite knowledge compared with that we now possess. Okay. So there are characteristics why qualities are controlled, and these characteristics must be accepted to anyone who are involved in process improvements or in the production. The first characteristic that a controlled quality will not be a constant quality. Instead, a controlled quality must be a variable quality. So the first characteristics of a quality, of a controlled quality, it should be a variable quality. And the second characteristic of a controlled quality is it should be distinguishable, constant variability within limits. So all the points, the variation should be the limits that we will set. And this limit, we will have to come up with the upper control limit and the lower control limit. Okay, so according to Schwartz, or Andrew Schwartz, he mentioned that a phenomenon will be said to be controlled when through the use of past experience. So there are baseline that we need to have, or previous data or available information, so that we can predict something and we can conclude that the variations are within limit and how the phenomenon may be expected to vary in the future. And here it is understood that prediction within limits means that we can state that at least approximately the probability that the observed phenomenon will fall within the given limits. So if the state is within limit, we can say that the process is capable or the process is in stable condition. Okay. So the point of the definition of Shewhart is that control is not defined as the complete absence of variation. Take note of that. Control is not the absence of variation. It is simply a state where all variations is predictable variations, or where all variations can be controlled. And it was also mentioned by Engineer Cabanlit that we need to determine the causes of these variations, the common cause and the special cause. Okay, so I have here a simple illustration or a figure of a control chart. It is based on the read beat experiment, wherein the sample size is 50. So earlier, before I over the discussion, there were rules that we need to follow for us to say that the process is stable or not. Okay, so as you've noticed on the figure, it was labeled with UCL. It's the upper control limit, and then we have the lower control limit. And the UCL and LCL is not defined by the customer or it's not defined by anyone, but UCL and LCL is based from the available information that we have in the organization. And these control limits are calculated again based on the statistics of the data. And these limits, the UCL and LCL, will provide the expected bounds of the process. So as you've noticed on the figure, the control limits in this example is between 0.217 and 0. So in this example, there were 50 sample size, or 50 beads, and out of 50 there were 10 beads which is color red, and then 40 beads are white. In this illustration, we can have an analogy example. If we are in the production area, or when we are in the production, these 10 beads, because in this, let us say that the manufacturing is producing 50 beads na dapat color white. But again, there are things which are out of our control na ay na-produce na 10 beads which are red. Okay? So let us say that these 10 beads are scrap in the production, or it needs to be reworked. Okay, so going back to the figure, the limits again are between 0 and 11, or 10 red beads, which are kung atong i-percentage, that's 0.20%. And all sample sizes or all observations should be within this limit. Okay. So thus, the control limits for this stable process provide a means of predicting future performance of the process. And let us consider, if this were the error rate of a key process, predicting its future performance would aid the budgeting process or the general allocation of resources needed to meet operational requirements, given the ways, example, these 10 red beads, or perhaps just provide an economic justification for process improvements. So again, when we analyze the chart, we identify the points or the groups which causes the variations, and then when we identify the variations, we have to go back to the cause and effect analysis when we determine unsa may rason nganong naani siya nga variation. Okay? So the values plotted in the figure vary from approximately 3 to 20% as what we have as what is presented on the figure. The control chart makes clear that the process is not changed, it is stable, and then it is in statistical control. Okay, so no one changed, example, no one changed the bucket if in anyang resulta and then no improvements were made, same bucket were used with the same percentage of lead beads. So needless to say, not all phenomena arise from constant systems of common causes. At times, the variation is caused by a source of variation that is not part of the constant system. So these sources of variations were termed as decidable causes, as what Engineer Cabandit has mentioned, and Deming calls these special causes as, and Deming calls this or termed this as special causes of variation. Okay. So we go now to the two variable, the variable control charts. So take note, class, that not not all type of data can be performed using variable control charts, or not variable charts cannot be applicable to all types of data. Remember, there are not like continuous or discrete data. Variable control charts are applicable only to the continuous data. Example, mga observation nato, time, temperature, mga height, mga inana. And variable control charts na ay tulo, na atay X-bar charts, and kaning range control charts, and SD, or the standard deviation control charts. Okay. So when to use X-bar R control charts? Okay, so when the process is stable, when based on your observation, the process have some minor variations, the X-bar R chart will help us to identify the process variation over the time. And then in the two charts, the X-bar R and the X-bar S chart, we assume that the data are normally distributed and the data are continuous. We use X-bar R chart when the subgroup size is more than 1. Take note of this, subgroup size is more than 1, or the subgroup size is between 2 to 10 observations. We use the X-bar R control charts. And if the subgroup size is more than 10 observations, we use X-bar S control charts. Okay, so as what I've mentioned, the data collected should be continuous. Example, length, weight, temperature, baron na yun, ana. So this is our guide when to use the X-bar R and the X-bar S control charts. After we know what chart to use, we will go to the creation of the chart. Okay. Sorry, muna bali. Okay. Okay. So the formula for the average and range control charts we have there. First is we get to compute the mean of the subgroup measurements. Example, subgroup measurements, the I-class, before I forgot. Example, you have subgroup measurement example, this in the observations nga ato ang makuha, or the data that we collect, we have to group these data nga naan nato. And then how we can compute for the N or the subgroup sa ato ang collected data is that pure n will determine us or will dictate us the upper control limit and the lower control limit for the different charts, the X bar and the R charts and the S charts. We need to know how many subgroups are present in your data. And once you know the value of n, you can obtain the correct constants. Okay? And the correct constants, these are standards. So natay table na basihan for us to determine the value. A2, A3, D3, D4, B3, B4. So to complete the control chart, we have to check the correct values of the constants. And sometimes this is very confusing when we create the control charts. So again, the value of n or the subgroup is the number of subgroup within each data point. For example, if you want to take temperature measurements every minute, and there are 3 temperature readings per minute, then the value of n would be 3. Again, subgroup ha, n. This is the number of subgroups within each data point. Okay. If you want your experiment to take 4 temperature readings per minute, then the value of n would be 4. So meaning if your boss or your superior wants you to have a data or readings, example temperature readings lang, or the number of defects or the number of the defects present or the number of defects in the production area every minute. And then he said nga 4 readings ang imuhang buhaton every minute. So the number of n is 4. Okay, so it is the number of readings per minute or per day or per year na giset sa inyong operation. So going back to the formula, when we create control chart, the formula is first we get the mean of the subgroups. Again, if you have, let's say example na kay, this is the summation of the variables divided by your n. And then in the XR chart, R, we know in statistics that it's a difference of the largest value minus the smallest value. And then we have here also the control limits for range charts. It is just the sum of subgroup ranges divided by the number of subgroups. Or if we when we create the chart, this would be our central line. Okay, and then to compute for the lower control limit for the range chart, it is just d sub 3 times the grand range or the average range. And then UCL or the upper control limit, it is the product of D4 times the average range. Where to get the value for D3 and D4, we are to base it from the table of constants. Okay, so base D3 and D4. From the table of constants, based on the number of subgroups that you have. Okay, and control limits equation for average chart using R, our average mean, or this is the grand mean, equals the sum of subgroup average divided by the number of subgroups. And to have, this is now the control limit for the X bar, the X bar chart, if we are to use the range. And to compute for your lower control limit, it is just your mean, grand mean, minus the product of A2 times the range, the R bar. And then for your upper control limit, it is just the grand mean plus the product of A2 times your average range. Same with the D3, D4, A2 and A2 is based from the table of constant. Okay. So please take note of the formula that we have, because later on we are to use all of this in when we are to make the X bar R chart and the XS chart. Okay. So for the average and standard deviation control chart, we have here also, first is we get the mean of the subgroup measurements. And then we are to compute for the standard deviation in each subgroups. And then for the control limit for sigma charts based on SR, we have here to get the average standard deviation, it is just the sum of the subgroup sigmas over number of subgroups. And for your lower control limit, it is just B3, B sub 3 times the average standard deviation. Okay. For the upper control limit, the UCL, it is just B sub 4 times S bar. Okay. And when we are to use average control charts based on S bar, we are to compute for the grand mean, which is the sum of subgroup averages divided by the number of subgroups. And to compute for the lower control limits, when we are to create a S bar, the LCL is the difference of grand mean minus A sub 3 times the average standard deviation or the standard deviation. And then UCL, or the upper control limit, equals average mean plus A sub 3 times the average standard deviation. The central limit for the S bar is the standard deviation, the average standard deviation. Okay. And the central limit for averages chart based on S bar, it's the average mean. Okay. So after we create the chart, we will interpret the data na graph sa ang chart. And how to interpret, it was already mentioned, there are 10, but I have here the 7 rules. Okay, so illustration lang ni siya. If you have these points outside the 3 sigma, so the process is not stable, or the process should be improved. It should be reviewed for us to control this point. So 1 point beyond the 3 sigma control limit seeks to identify points that are random or outliers. Example of special causes, it should be it could be the equipment, environment, and the process. Another rule that makes the chart out of control, or that makes the points or the observation out of control, when 8 or more points on one side of the center line without crossing. So atong makita din ha, there are 8 points, consecutive 8 points on one side of the center line. So another rule that makes the process unstable is when there are 4 out of 5 points in zone B or beyond. So it's very clear that if we have the same chart, the the process is out of control. Another rule, if 6 points or more in a row steadily increasing or decreasing, then with this, our process is not stable. Fifth rule, 2 out of 3 points in zone A. Example, you can see there are 3 points who are in zone A. Consecutive 3 points in zone A, so it is not stable. Rule number 6, if there are 14 points in a row, alternating up and down, as what you have seen in the figure. So if ingon ani ang resulta sa atong chart, it makes the process unstable. And the last rule that I have is any noticeable, predictable pattern or cycle or trend. If mag-ingon ani, in this illustration, there are 3 consecutive points in the same zone. And then after that, 3 consecutive points on the same zone happen, it makes the process or it makes it out of control. Okay. So let's apply the formula and then how to interpret the data in a given problem. Okay. So nata din he control chart. So this will be our guide as to the factors of control limits. Example, for if we have 4 sample size or subgroups, these are the values nga to gamiton. So let's try to compute. Maklaro ra ang table. Yes, miss. Okay. So we have here, these are sample 1, 2, 3, 4, 5. These are your n. So we have 5 as the value of n. And there are 25 groups. 25 ni sa kabok. So the table also shows the average in each group, and then the range in each group and the sigma or the standard deviation. The table also presents the average or the grand mean of the total observation, which is 99.5, and then the grand range or some references denote is this as R bar, which is 14.76, and then for the sigma, the average sigma or average standard deviation is 6.218. Okay. So if you can still remember, we need to compute for the R bar. So the value for R bar was sum of subgroup ranges divided by number of subgroups. Okay. So in the illustration, the value of our I is kani ato anang gikuha, which is 14.76. You get the total of the range divided by number of subgroups, which is 25. There are 25 subgroups. Okay. After we get average range, which is 14.66 in our chart, this will be our central line. Okay. Next is we have to compute for the lower control limit, which is D sub 3 R bar. And based on the table of constant, if the number of subgroup is 5, DR is 0. Multiplied by 14.76. So our lower control limit in the R chart is how much? Is the value of our LCL is 0. After we have the lower control limit, we compute for the UCL, and the formula for UCL for the range chart, it's D sub 4 times R bar. And if we have N, which is 5, the value of D4 is 2.115 times our R, which is 14.76. So our UCL is filament class. In two decimal places, that's 31.22. Okay, thank you so much. So using these values for our R bar, which is 14.76, and it will be our control central line, and then our lower control limit. We now have the upper control limit for our range chart. We have to, we can now plot this points in a chart. So we can plot the points. We can do it manually. We can also use with the aid of Microsoft Excel, so that the illustration or the lines will be kanang mas presentable. And then there are, I don't know if you're familiar with Minitab. We can also graph or create the chart using Minitab. And to use Excel when graphing a range chart, we can do it this way. Okay, so I'll be showing to you how to draft the range chart using the Excel. Okay. For a while. Okay. I'm presenting to you my Excel so that we can graph the R chart that we have. Okay, so earlier we computed the value for our upper control limit, which is 31.22, and then our central line or the R bar, which is 14.76, and our lower control limit for the R chart, which is 0. Okay, so we have to highlight the limits that we computed, and then with the subgroup ranges that we have. Okay. And insert chart. So this is now the R chart. So this is the blue line is our upper control limit, and then the gray line is our lower control limit. This is our central limit, and then we have the subgroup ranges. So we have 25 ranges. So based on the R chart, what can you conclude man sa ato ang na-prepare na chart? Can you see a point which is out of control? Are there points which are beyond the control limits? Or based on the condition in interpreting charts, can we conclude that the process are stable or within our control? Hello? Stable ra ba ang ato ang? Okay, within Ramis. Yes, very good. Okay. So if it is the case, if the R chart is within limit, we can now proceed performing the X bar. So let us remember that in interpreting X bar R chart, we always examine the R chart first. So if the chart or the values in the R chart are out of control, that means no need to proceed performing the X bar chart. Or the values in the X bar chart that we are to draft or we are to create are not accurate. So if there are points which are out of control in our chart, again, we need to stop the process. We identify the special cause and address the issue, remove those subgroups from the calculations, okay? And once the R bar chart is in control, then review the X bar chart and interpret the points against the control limits. Remember, all the points to be interpreted should be against the control limits, but not specification limits, as what I have mentioned, that specification limits are provided by the customers. Okay. If any points out of control in X bar chart, identify the special cause and address the issue. So since the points are within our control, we can now draft our X bar chart. Okay. So for the X bar chart, using R, the formula is again, control limits equation for average charts using R bar. Have here X power. Sum of subgroups averages divided by the number of subgroups. Okay, and then for the LCL, for average charts using R bar, that's average, or sometimes there are references that call this as grand average minus A2 R, yes, R bar. And then for the LCL, UCL rather, equals grand average minus a plus A2 bar. So based on the given figure or table, our grand average equals 99.5. Okay, 99.5. Substituting the value for the average mean to have the LCL, that's 99.5 minus A sub 2. Okay, if you have the value of your N, which is 5, your A2 is A2 is 0.577. 0.577 times the value of your R, naman tong R na to, 14.76 times 14.76. So our lower control limit now is what is the value of our LCL for average charts using R bar? This is 99.5 minus the product of 0.0577 times 14.76. 90.98. Okay, thank you. 90.98. Okay. And our upper control limit for average chart using X bar is using the formula 99.5 plus 0.577 times 14.76. The value for the UCL is 108.2. Okay, thank you. So 99.5, or the computed grand mean using R bar, this will be our center line. Okay, so let us now draft our average chart using R bar. Okay, So same procedure. You highlight the values for your limits. So again, you can do it manually, and for the sake of discussion, nagamit tayo og Excel. And then highlight the values of the sample average, which is 25 sample average. Insert the graph. So this is our, sorry. This is now X bar or the average chart, X bar chart. Okay. So based on the chart, is it within limit or out of the control limit? Okay, within limit. So the R chart, the X bar chart that we have are within limits. So this shows that the process is in statistical control. So the limits of variability for this process are predictable using the control limits that we have. So since the process is in statistical control, we can also make predictions of our availability to meet customer requirements. So process capability will be discussed after the attribute charts later on. So we already created X bar and R chart, and then we go to the second nga purpose for this discussion is to create the X bar and then the X bar and the X bar chart and then the S bar. Same ruling if the S bar chart is the first chart that we're going to examine. Okay, and then if the X bar chart using S or the standard deviation limits, if the values are out of control in S chart, that means the X bar chart control limits are not accurate. Again, if the points are out of control in S chart, remove those subgroups from the calculations. Once the S bar chart is in control, we are to review the X bar chart and interpret the points against the control limits. Same also, we need to plot all the points and interpret it against the control limits that we have or we calculated. If any point out of control in X bar chart, we have to identify the special causes and address the issue. Okay, so using the same values that we have, let us compute for the lower control limits and upper control limits using the S bar or the standard deviation. Okay. We now have the value for the S bar or the average standard deviation, which is 6.218. And this will be our central limit. So SD is 6.218. This will be our central line or the central limit. Okay, and then to compute for the lower control limit on the S bar, the formula is LCL equals B3 S bar. And then for the upper control limit, it's B sub 4 S bar for the average standard deviation. Okay. So if the number of n is 5, B3 is 0. B3 times our SD or S bar, 6.218. The LCL in our S chart is 0. And if the number of n is 5, B4 is 2.089 times the value of S bar, which is 6.218. So our UCL for S chart would be okay, 12.99. Okay, thank you. So we now have the limits for the S chart. And then after that, we are to compute for the control limit equations for average charts using S bar, on S bar rather. So same, we have the value na, based on the table, we have the value of our grand mean, which is 99.5, and this will be our central limit or center line. And then the LCL, lower control limit, is computed using this formula, A3 S bar. And then UCL equals grand average plus A3 S bar. Okay. So grand average, that's 99.5. If n is 5, the value for A3, 99.5, A3 equals 6.218. This is 6.218 times our S bar, which is based on the given value. This is sorry. If the number of n is 5, A3 is 1.427. Okay. Again, if n is 5, A sub 3 is 1.427 times the value of our S bar, which is 6.218. So LCL is equal to okay, 90.63. Very good. Okay, and then our upper control limit for average charts based on S bar, this is a 99.5 plus 1.427 times 6.218 equals 108.108.37. Okay, thank you. After we have the values of the control limits for the average charts based on R and the control limits for our S chart, we can now plot, or we can now create the chart. Okay. So using for a while. Okay. So you highlight the values of your limits in the S chart, the three limits, and then highlight the value also of the sample standard deviation of the 25 groups. This is the chart. This is our S chart. Okay. This in our chart. Is it within or out of the limit? Okay, within. Still, our S chart is within the limit. Okay, so since the S chart is within limit, we can now proceed to our X bar chart using the standard deviation. Okay, so we have here the values of the limits of the X bar on the standard deviation, and then highlight the values also for the sample average for the 25 groups. So this is the X bar chart. This is X bar on standard deviation. So the process is saman. Is it stable or not? Or is it within limit or out of the limit? Okay, stable. Based on the four chart that we have, the conclusions that we made is the same as the range. Okay. So the average and sigma control charts and the average and range control charts are stable or are within limits. Okay. So let's try to have another exercise. Simple lang. You have here in a manufacturing industry, the plate thickness is one of the important critical to quality or the CTQ factor. During measure phase, project team performed the process capability study and identified that the process is not capable or it is less than 2 sigma. In analyze phase, collected 20 sets of plate thickness samples within a subgroup of 4. So we have here 20 samples with 4 subgroups. So the value of n is 4. Based on the value of our n, our constant factors, A2 is given here also. Okay. A2, which is 0.0729, A3, 1.628, B3 equals 0, B4, which is 2.266, B3 equals 0, and B4 equals 2.282. So on your paper, compute for the R bar, the LCL, and the UCL of the R chart. And then compute also for the X bar, and then the LCL and the UCL using using the range, sorry. So compute for the R bar, and then the LCL and the UCL. Compute also for the X bar, and then the LCL and the UCL using the range. Okay, I'll give you time. I guess 5 minutes to compute the value. Or 2 minutes lang. Okay, I will. Okay, here's the formula for the X bar R chart. Okay, please inform if you have already the formula so that I can proceed to the slide problem. Okay, thank you. Okay, so do you have the values now? Okay, hello. Hello, can we now have the values for our R bar and lower control limits and upper control limits of the R chart, and also the value of the X or the X bar and its um, lower and upper control limits using the range. If you are done, you may type in your answer in the chat box. OTR, it's 11, 11.7, correct? LCL, it's 0, okay. And then the upper control limit, it's 27.04. Oh, correct, Miss Bernadette. Okay. Oh, sorry, ma'am. Okay. So again, for the R chart, the R bar, it's 11.85. The lower control limit is 0, and then the upper control limit is 27.04. Okay. Okay, how about the grand average or the average X bar? That's okay, 29.88. And the value for the limits, the upper and control limits on range LCL, that's 21.24, and UCL, it's 38.51. Okay, correct. Okay. So if we are to plot these points, if we are to create the X bar chart and the range chart of these values, it would give us okay. Based on the chart, what can we conclude, man? So on the R chart, as you've noticed, there are points. Actually, there are 2 points which are out of or beyond our upper control limits. So these are the points. In the observation, these are the group 9 and 10. So if we have determined that these are the points which are out of the control limit, we have to investigate the causes of this variation, or uh, what makes it these points reach beyond our upper control limit. And in the X bar chart, there are also points. It's very evident. There are 1, 2, 3 points, 4 points, which are beyond our uh, upper control limit. And there are also 4 points which are also beyond the lower control limit. So again, we need to investigate these points to determine the causes, and we need to improve our process. And after we make improvements, we have to revise our charts and to see if the improvements that we propose or that we implemented makes the process stable. So again, if there are points which are out of the limits, investigate and then make improvements. Okay, so note that a process is in control. That indicates means of the process is stable and it cannot be predictable. A process is unstable, that does not mean it is a zero defect process. So even if the points are within the limits, take note that these area, kaniman siya, these are the special causes man. And if you've noticed, there are variations on the points. These are the common causes. The process improvements, when we make a proposals or when we investigate the process, we can still improve anemia. Remember to never put specifications with any kind of control chart, and the points on the charts are comprised of averages, not individuals. Specification limits are based on individuals and not on averages. The operator might have the tendency to not react to a point out of control when the point is within the specification limits. The X bar S chart or X bar R chart helps to avoid unnecessary adjustments in the process. So therefore, statistical process control will guide us or will lead us what pointsman or where to start our investigation that makes the process unstable. Okay, so that ends my presentation on the X bar R chart and X bar S chart. Thank you for your participation in answering the exercises that we had this afternoon, that we have in this discussion. If you have concerns or questions or point of clarifications, I guess we still have time to clear everything. Yes, pwede ra kaayo sir. XFL. Katong ata is okay. Okay. So, pwede akong i-send lang ni Engineer Cabanlit. Pwede ram, miss? Naana lang ako ihatag sa imuhang Excel file.
Yes, pwede ra, ma'am.
Okay, ma'am. You're welcome. Yes, ma'am.
All right. Thank you so much, Ma'am Lori May. So, do you have questions, guys, with regards to creating the UCL, LCL, and CL for XNR and XNS? Say questions. Do you know how to derive the A2, A3, D4, D3 already? Diba ramon sa akong pagkuha? Okay, sige. Ako lang na i-share, i-discuss how to get that. So, mamang po daw na-observe kang ma'am, no? Available na siya daan, but that one, you have to find it on your own. Okay? I will not give that to you. So, how to do that? Let me share screen.
Ay, okay, ma'am.
Okay, ma'am. I think makasapaw ra sad ko. I'll
Okay.
go to layer. So, di ba you notice that there is an attachment in your courseware sa ubos. Kabantay mo ato. That is your table of constants. Okay? That is your table of constants. Now, you are to find that by looking for the sample size and the n. So, let me open that one. Okay, here. Asan to ang alright. Share screen. Okay, this one. So, you can see my screen na, no? Okay. In getting the A3, A4, and D4, D3, guys, this is the purpose of the attached table of constants. So, okay, this one. This is your table of constants. So, for example, let's say, sa first example ni ma'am, pila man ang value sa n dito. So, again ha, the clue here is, the sample size is the number of items nga imong murag batch na nimo siya. But di na siya mawang inyong gamiton. It is the observations. So, the small n here represents the observations. Alright? So, for example, let's say, pwede nimo mapakita balik, ma'am, ang katong presentation nimo ganina, katong ipa-find nimo ang solution.
Or,
Again, ma'am.
okay, ma'am.
Sige. Okay, this one. No? Kabantay mo, how many samples do we have? Sige. Type in the chat box. Or you can unmute yourselves. I want to hear your voices. How many samples do we have? Ayo, wait tao. Unmute yourselves. Pila man ang samples?
20,
20, ma'am.
20.
Pila man ang observations?
4.
4. Okay. Question. In looking at the table of constants, unsa man ang ato ang unang tanawon? Unsa man ang ato ang tanawon? The sample or the observations? Unsa man? Sige, ighadlok. No, it's not both.
Sample.
No, it's not the sample, but it's the
Observation.
okay. So in that case, no, that's a very simple example. You have 20 samples, but you only use the 20 there to compute for the grand average. Average of the averages. Diba? The x there is double barred x. Right? The formula is double barred x. Meaning to say the average of all the averages. So the 20 there will just be used to compute for the grand average. So you get the, di ba, for the sample 1, kuhaan mo average. Sample 2, kuhaan po mo average. Out of the 4 observations. Then total, di ba, imong i-average tanan? Right? So in that case, your observation is 4. So therefore, I will share again the table of constant. 4 man na siya. And the formula for, what's the formula for the upper control limit? It's A. So, barred X. Sige, ako i-share ang kaniha ang formula diri. The formula for, okay, diri, this is already discussed or presented very well, no, nga courseware. So, diri, no, itanaw nimo, the formula for barred R is, here, double barred X plus A2 barred R. Yang ma'am, nganong barred R kay dili man double barred R? Because ang imong gibuhat man good from sample 1 to sample 1 4 observations to get the range, di ba it's highest minus lowest value. Sakto? So dili siya average na range. So for sample 1, gikuha nimo ang range, sample 2 gikuha na pud nimo ang range, and then after all getting all the ranges of the 20 samples, gikuha na din nimo ang average. Actually, it's just barred R, not double barred R. Kasi barred X, double gid siya because nag-average pa ka ani, nag-average pa ka pa paubos. Na-gets ra guys? Now the A2 there should be derived from the table of constants. So A2, adto ka mo tan-aw sa 4. Okay, so adto ta sa 4, A2, 4. So ari ka sa kani. Okay, A2 at 4. Di ba pila ang value? 0.729. Motong ang gihatag ni ma'am na example or sa constant is 0.729. Na-gets? Gets? Wala.
Yes, miss.
Yes, miss.
Yes, miss.
Next, the formula for the lower control limit is the same, but this time it's A3, pero minus na siya. Right? So, ganina plus, kani minus. Same gihapon ang imuhang value sa A2. Asa naman to? Okay. So, sa'yo na gid kayo memorize ng formula, guys. For the X and R, it's double barred X plus A2 barred R. Then the central limit is the average, the grand average. Then the lower control limit is just the subtraction. Means si A2 barred R, guys, mo na siya ang ihang tolerance na gihatag. It's the error or the dispersion na iyang gihatag. Okay, di ba you notice that barred R is a measure of dispersion. Right? A measure of dispersion. So, nito sig multiplyan siya og kanang constant na error, then imong i-subtract for the para naa kay range. No more na yung use. Then the central limit is still the barred X. Okay. S, guys, you cannot use X and R and X and S at the same time. They have different uses. Now, when do you use X and R? You use it, di ba, you notice that a range is only applicable if your data is small. Kaya para i-determine mo sa highest o lowest, it's easier. Although Excel will do that for us, no? Maximum minus minimum. Pero if you're really going to do it manually, you cannot check all the numbers if it's already more than, let's say, 20 observations. Mabuang nakaanag tinanaw, right? If it's done manually. That's why X and R is only used if the data is less than 10 or 12. Actually, 12, pwede pa magamitan ng R. But 10 or 12 below, that is X and R. More than 12, so 13 and above, especially if 35 or 30, it's already a kanang population, di ba? Considered na population, we will use X and S. So the dispersion that we're gonna use is already the standard deviation, not the range. Gets? Clear? Ayo?
Yes, miss.
Sabtan? Okay. Now, ang next na to na question, for the UCL, it's the same for R. Alright? D4 and D3. Now, nakoy question, is it possible that if the X and R process is capable, but for the R, it's not capable? Is it possible? When we did the X and R, or XNS kay process is capable. Pero if we do the R or the S chart lang, the X chart rather, possible siya, process is capable. But pag R chart, dili siya capable. Is it possible, guys? What do you think? Sige, don't be afraid. All opinions will be accepted. Sige. Is it possible? Ayun, ikaw. Nakatulog na mo? Again, my question is, if X,
Another question.
okay, sige. Again, I'll repeat ha. X and R charts are two different charts. Let's just say for the X chart, it says that process is capable. But pag R chart, the process is not capable. Is that possible? Okay, for Jonalyn, it's not possible. How about the others?
Not possible gap sa ako, miss.
How about the others?
Not said, miss.
Not? Okay, so inani ni siya nga scenario, guys. The X chart is actually duha iyang gibasihan, no? It's the mean and the range or the dispersion. So meaning to say, if it says really that kanang capable ra siya in terms of its average, let's say iyang measure sa length or sa width or depende kung saan gi-measure, then if it says process is capable, but that is in terms of the mean, okay, or the average or the size. But if the range is, let's say, nilapas siya, no, na ay ni gawas, meaning to say it goes beyond the tolerance level in terms of the dispersion or the variability of data. And based on my masteral class, that is possible, no? According to Sir Alex, that's possible. Because the R chart, as you notice in the formula, it's just D4 bar R. Yung focus is the range, not considering the mean. So potentially, pwede gid siya that mulapas ang or muingon si R chart na dili siya capable based on its range. But again, range is also kanang contestable nga information kay let's just say basin ka na nga range is too strict based on your parameter set, or maybe it's kanang too luag, no, or too sitaw na di kayo ka strict with your kanang with your ranges. But according to Sir Alex, potential gid na siya. Okay, especially that there are times the LCL should have been negative. Because in your, guys, in your table of constants, naagid tayo negative values. Ano, dili siya, walay negative, but subtract, it leads to negative. So like for example, no, let's say double barred x minus A2R bar. Dayon, let's just say your A2 is large. Kung tanaw na nato mathematically ba, your A2 is large, mean to say, it subtracts all leading to a negative value sa inyong double bar x. So that means negative gid imong value. But you cannot draw a negative LCL. So again, guys, the formula for LCL is it should be greater than 1. If mo negative na gani, not greater than what, but greater than 0 rather, or it should be positive. If negative siya, automatically your LCL is 0. Okay? Because, let's say it's an average weight or average width. Wala may negative na width, negative na height, right? So ideally, 0 is the lowest control limit. But mathematically, dili gina sila mag-equal in ka control chart nimo. Na sub-10 ra, guys. So, usually, the S chart and the R chart gets the negative value. Mo na nga, ang iyang formula is greater than 0. So, if mo negative na siya, automatic 0 ang imuhang LCL. The sub-10 ra on how to get the values here. So, this is very useful. Alright, then for the B4, so tawagin mo B4 at 4, 2.266. B3 at 4, 0. Di ba? A3, para sa X and S, 1.628. Okay, so kani gamit gid kay ni siya. We will meet a lot of this one. Inig ka, X and M are also nato. Pero usually, si moving range man good is, if your production is also like every time, sige ka og ka ng produce, no? So, if wala ra kayo kay production, usually di kayo magamit sa moving range. So, again ha, the difference of XNR and XNS is you will only use XNR if it's less than 10 or 12 if the observations, okay, not the sample. Basi maingon mo nga, ma'am, 20 man to ang sample, nga nung nag-XNR naman ka. Again, observations ang tanawon. Gets? It's not the sample size, it's the observation. The sample size is only used to compute for the average. Okay? What else, man? Yeah, so you were taught already, my ma'am, how to make the charts, no? So, as you can see here, ato lang i-review. So, I believe so that you know already how to do that. So here, no, sa inyong X and, is this the X and R example? Yeah. So again, the formula is double barred X plus A2 barred R. The central line is the grand average. Then the LCL is the double barred X, but this time minus. Okay, then A2 is derived in the table of constants. For the R chart, it's D4 barred R. Then the center line is the average of the ranges. Then LCL is the D3 times the average of the ranges. So, inig-drawing ninyo guys, for example, kanino? Okay, question. On this example, how many observations do we have per sample? We have what? How much? We have 5, correct, April. But how many samples do we have? How many samples do we have? 25, correct. So, in getting the grand X, simply, you get the average from sample 1, observation 1 until observation 5. Mo ni gibuhat ani. Kabantay mo? Mo na siya. Kani nga part. Okay? Then, divide siya by 5. Kasi syempre, there are 5 observations to get the average for the first sample. Now, after getting all that, to get the double barred X is simply you get all the averages or bar X of all the sample size. So, mo na iyang gibuhat. X1 until XM or X25 kabuok. So, ang total sa tanang averages is 37.64. Then, mo na ni ang gamit ni 25. That is to just get the barred R. That's 1.5056. Same goes with the range. So, si range, subtract na gyapon. Tanaw ni mo sa lowest, so 1.3235. Then ang highest, let's say 1.6914. To get the range, subtract na silang duha. Then, i-compute na dahil ang average of the ranges. So, as you notice, unsa man ang atong i-use, again, in looking at the formula dito sa table of constants. Not formula, but the value of A2 and A3. What are we gonna use? Is it the N5 observations or the N25 samples? Jay, gamiton gani, tanaw sa table. Observations, which is how much? 5. Okay. Sige. So, nasabtan ra ha. So, tanaw na to. Is it correct ba ang pag-choose sa A2? Is A2 really 0.577? Or D4 is, asa tong D4? Kasi yung dito nga D4. Yeah, D4 is 2.114, then the D3 is 0. Sige, panahon na to. Panahon na to. Okay. So, arita. Alright. So, 5, A2. Pila ang value ni A2? 0.577. Correct. Dayon, your D4. Diri ang D4, no? D4. Nasa last. 5. 2.114. The D3 is 0. Okay? Nasabtan ra nga anong mauna ang mga values? That is because of the observations. Alright? So, sa yun nagid kayo na ang XNR and XNS, guys. Then after that, you plot that. Okay? Katong gibuhat ni ma'am is another way to see wherein you just input the bar X of all and then the bar R. Pero naa po yung mas dalian na, guys, no? So, ang dalian na is just you have to adjust lang the Excel, no? Drawing sa scatter diagram. So, wala lang ko example diri values nga pwede yung nato i-portray. But I have here, sige, I'll try to show. Wag na ako'y kuha na Excel ana. Wait ha. Ito ipakita. Mhm. 20 semester. Sige na, 7 minutes na lang and we're done for the day. Okay, dere. This is an X chart example. So let me share my screen. Goes na ba? Exit. Okay, please ko turn on sa lights. Kumagak naong ba kayo? Okay, here. Sige, let me share my screen. Ayun. So for example here, guys, this is another way of portraying also, no, or creating a koan. Can you see the Excel ba? Yes?
Yes, ma'am.
Okay, sige. Okay, it's dako okay. Okay, akong yan. Alright. So, ang mahitabo, guys, for example, no, here, you have 5 samples but 3 observations. So, again, when you get the value, you just look at number 3. Then, you got the averages of each and then the range. Then, naka-UCL, no, muna niya itong formula. So, paano ni siya kanang direct na siya. But how to plot that is, ginanira na ko siya, no? So, lahi po di siya nga method. But pwede rin po ito ang gibuhat ni ma'am, no? That's the easiest way. But here, akong gibuhat is, so let me delete that one first. So, akong gibuhat is, I highlighted the sample and the averages. Then, I go to insert, and then scatter diagram, para makita gina to if nasud ba siya sa zone or not. So, kana, no? And then after that, kada ko ba ano na ko ay there. So akong padak-an gamay. Ito cute sila na. Okay, makita na kung cute ba sa mga values. Sige lang. So, anyways, ay naku, ang nagigil. So, ang next na itong buhaton is, we will just change the vertical axis, no? The vertical axis or the Y, siya X and Y ba? The Y na axis, ato lang na siyang usbon based on the UCL and the LCL. So, your center line is 1.4947. We're assuming na ato na siyang na-solve, no? So, 1.4947. So, ang buhaton na to guys is i-highlight lang nato na siya. Then, format axis. Format na to sa axis kay our maximum is the UCL. So, pila yung value sa UCL gani? It's 1.5560. So, arita sa, so, Kani, axis options. So, ibutan na nimo sa maximum is the UCL, 1.5560. Then, sa minimum is the LCL, which is 1.4333. Okay, nasa na to? So, 1.4333. Now, ang next atong buhaton is the major difference. So, ang major difference is we will just subtract 1.5560 and CL. So, in that case, that's 1.55 minus 1.4947, 0.6014. If ato po ni subtractan sila, same ra gid na sila. Because same naman og gi-subtract sila, di ba? A to R man gihapon. So, tanaw na to diri sa asa na to? Sa x-axis. Nawa de. So, for the major, ato na siyang i-change og 0.0614. Okay? Nya, inigtanaw na to. Ano man yun siya? 1.55556. 1.4947. Sakto man. Nasa sub. Wait lang. I think tungod kay wala natin abako. Ha? 1.4333. For 1.5560. Ay, nasa reply ko. 55. Masakto man, 5560. Dapat equal na sila. 1.5560 maximum. Ayun, dara. Reset or di kina-auto. So, I don't know ano ni iyang buttons kanang gagmay. So, as you can see, and if ganahan jud gani mo guys nga makita gid ninyo ang A, B, and C zone, i-divide ra ninyo ang iyang kani-kaning differences into 3 para makita gid nimo kung kinsay mga nasud sa A, B, C, D nga zone. So, ato na siyang kuanon ha, ato i-figure out daw. I-try na to create a zone. So, inani ang tanaw or now sa imong control chart. Pwede ra gid na siya naka-scatter diagram. Pwede ra pud og katong pareha ganina which is connected no or line graph. So, you can change that by format data series. Change layout din na siya dapat. Change series chart type. Imong i-line. So, pwede ra po na mo siya i-line. Or line with kanang may dots. So, pwede ra po din na, no? Line with dots. Now, if gusto ka makita nimo ang differences sa A, B, C, D nga zone, di ba, pila man kabuok, pila na kabuok formats na or difference na. Tulon na, no? 1, 2, 3. So, pwede na to i-divide si 0.0614 into 3 pag yun. So, ang iyahan ng gap is 0.020046. Sige, try na to if kaya. 0. So, ang major now will be 0.0246. 0.2046. Okay, so kana. So, makita na dahil ka nga, this is the center, and then, wala na nakita ang kung ano. Di naman good equal ang difference. Ako daw ng 0.02046. Sakto ba? 0204. 0204. So, ato i-format axis. So, mas complicated niya akong gibuhat actually. 0.02046. And then, i-reset na to. Okay. Di lang siya maabot og 1.5. Mag-usab niya ang atong highest 5560 be. 5560. Okay. Yeah, so kana. So in that case, makita na nato nga the first one is near the central line. The second one is near when patong siya sa zone B. And then the third one na sa zone B. And then here is near na siya sa zone C, near Rapod. And the other one is zone C also. Okay? So meaning to say the process capability, the process is still capable. Okay, so kana if you want nga ma-separate with sila by zone. Alright? So it's up to you guys if unsa inyong mas kuan, if mas preferred. If katong ganina nga gi-show ni ma'am nga butangan lang nimo tanan sa upper control then lower control then highlight para mo makita siya og range, or you will adjust the axis. Okay, so both will be process control charts gra gihapon. Okay, kaya ang importante ani is you identified correctly the UCL, the CL, and the LCL, and you know how to view if it's capable or not capable, and you know how to draw or make the control charts. Just in case you will be tasked to make control charts in the future. But karon guys, kinanadjud tay mga freewares nga mo diretso na siya og make og control charts. So naa ko'y software ana, but later lang sana nato siya ipakita. For now, we have to know how to do it manually para in case in the future, we know how to interpret. Okay? Questions? So that is just two of the many charts pa nga ato i-discuss. Questions? Nasabtan na how to get the barred, double barred X, the barred R, the A2, the A3, okay? So ang standard dev guys, dali ra kay na, no? You know how to do that in your calculator. You're taught on that how to do it in statistics. Tapos if it's in the if it's in Excel, it's just stdev, di ba? .p if it's more than 30 samples, if less than 30 samples, we use .s for sample, di ba? Anaon na siya mas dali, no? Questions? Wala na questions? Sige, so if wala na questions, mag-picture ta with Ma'am Lorne, no, para to i-send sa College of Engineering and Architecture that she conducted a lesson with you guys. So kindly turn on your camera, everyone. Para natay documentation. Thank you so much, ma'am. Sige, asa naman mo guys? Stop recording na ko.